So in this video, we're going to do some examples of derivations with indirect derivation. So let's get started. So we have our 6 steps, and the first step is always to show the conclusion, so we'll go ahead and do that. Our second step is to make an assumption. Now we should always be making an assumption, because we can always make an assumption. If we're trying to show a conditional, we can do assume CD, and if we're not, we can always do assume ID. We can always do assume ID. We prefer to do assume CD when we can. So let's take a look at what we're trying to show and decide which kind of assumption to make. So what we're trying to show is a conditional. That's arrow there is the main connective, and so we should make a conditional assumption. So we'll do that. Okay, so good so far. Third step would be to bring in the premises. There are no premises to bring in, so we've done the third step. Fourth step is to apply our inference rules. Well, we could split up line 2. So we could say simplify left and simplify right, and we have P on one line, Q on another. That's about all we can do at this point, and so we should go to our next step, which is to do a subderivation. The derivation is stuck, so we do a subderivation. What subderivation should we do? We should do one that will help us complete the derivation, ideally one that would help us that would let us box and cancel. Well, if line 1 is a conditional, so if we get its consequent, we can box and cancel, so let's show its consequent. Okay, we have a new, and in fact, we could have done that on line 3 even before we applied our inference rules, because whenever we're trying to show a conditional, it's never going to hurt to show the consequent. And we could have set it up like this, and eventually done the simplification later. Doesn't matter. Let's go back to the way we had it. So we have this subderivation, and whenever we have a show line, now we want to make an assumption. So we should make an assumption because we just got our new show line. We can do a conditional. So if we can do assume CD, that's what we want to do. If we can't, we should do assume ID. So we have to ask, can we do assume CD? Well, we can do assume CD only if we're trying to show a conditional, but we're not. This is a negation. So assume CD doesn't work, and if we're ever not sure, we can always just check. And the computer will give us an error message that the show line is not a conditional, and so we cannot do assume CD. And so we should have said instead do assume ID. There we go. We have our indirect assumption. So now we want to go back and see if we can use our rules again. So we look at line 6 and we say, well, it's a conditional, so if we have the antecedent, we can do modus ponens. Lo and behold, we do have the antecedent on line 3, so we can do modus ponens with 3 and 6, giving us negation Q. What can we do with negation Q? Well, we might notice that, oh, hey, 4 and 7 are contradictory, so we can do ID. So we might say 4, 7 ID. But we're reminded that line 4 is not within the current subderivation. When we're going to box and cancel a line, like line 5, that's the subderivation we're working on as of line 8, that's the show line we're working on as of line 8, then the lines we cite have to be beneath that show line. So the first thing we need to do is bring down R with the repetition rule, and now we have the contradiction beneath our show line, so we can say 7, 8 ID, saying that 7 and 8 are contradictory. So now we've boxed and canceled line 5. With line 5 canceled, we can use it. Line 5 is the consequent of line 1, so we apply CD to line 5, boxing and canceling line 1. Good. So we see that sometimes we'll make an indirect assumption not at the beginning, but later on. And I want to illustrate one other point with this derivation. So here we got our contradiction was with Q and not Q, and that's fine. But we could have done this differently. We could have said, let's apply dn to line 4, and let's do mt with 6 and 7, because 7 is the negation of the consequent of 6. So we do mt, giving us negation p. We bring down 3 now, which is p, and now we have a contradiction between 8 and 9. So there are different, and so here we canceled with the contradiction was p and not p. Here, before we had the contradiction q and not q, and either is good enough. Indirect derivation doesn't care which contradiction we use. As long as we get a contradiction, that's good enough to show that the assumption is false. The assumption leads to any contradiction, the assumption is false. The assumption led to this contradiction. The assumption is false. And so this show line is true. So we're going to go ahead and CD that, and again, we're done. Good. So in our next video, we'll see more examples of indirect derivation problems.